I gave you an agenda. And the idea with the agenda, you may want to bring the agenda to class or have, this is just kind of the outline for what I'm going to cover. And so I do want to talk a little bit about the necessary content of what was going on there. So most of you said that over time, what happened to your visual perception? You were able to see more and more over time. Okay, and the question is, how come? Does anybody know how come? Does anybody know in your retina you have two types of receptors, which are kind of pointed out a little bit there. What is one type of receptor in your retina? You have your rods and cones. Does anybody know the differences between the rods and the cones? Are they similar? Are they different? Go ahead.
You have more rods than cones, and your cones are dependent on seeing colors, and you have 3 different kinds of colors.
Bingo. So you said a lot of very good things there. You have a lot more rods than you do cones. You have a lot more rods than you do cones. The cones are very good for seeing color. Does that kind of summarize what you said? Any other things we know about rods and cones? Okay, so what I'm going to introduce to you here, and this is going to be kind of part of what's going to be happening mostly in the class as opposed to the intro stuff we just did. There's something called duplicity theory. Duplicity theory says the following. Duplicity theory basically says you have sensory receptors. In this case, in the visual system, what are your sensory receptors? The rods and cones. The rods and cones, the sensory receptors for sensation, basically they are made up in different ways, and they have basically different specialties that they allow behaviorally. So you have different, duplicity theory says you have different sensory receptors visually, the rods and the cones, and the rods and the cones do different things. So when the lights were off, what was more at work when the lights were off? Was it more the rods? I realize I'm kind of my back's to some people here. Oh. Sorry, just learning. So the rods and the cones. What was working more in the dark?
Your cones or rods? Your rods.
What's the rods or cones? Why would you say the cones?
I have no idea. I don't know anything about this stuff. But
Okay.
she said rods were colored more than anything, so I figured the opposite.
So you figured the opposite because you just wanted to disagree with her?
No. Because, I don't know.
So the cones, as was correctly stated, work a lot more with color. When the lights were off, how was color perception? Did you get any color perception whatsoever? Virtually none. It was light and it was dark. So when the lights were off, it was the rods that were at work a lot more than the cones. So the rods were really at work a lot more than the cones, and I put this visual in, and when you write up your outline, you can actually copy and paste some of this information. Like this little visual kind of explains things in a particular way. What do you see in number 3 here, rod circuitry in the retina? I'm just speaking this out loud so that the folks online kind of get the same situation. What are you seeing here? We have rods. Rods are converging into what kind of cell in your retina? They converge into, what does it say there? A bipolar cell. And how do they do that? How would you call that circuitry? What's going on there? Is it just like one straight line? Is it one rod to one bipolar?
15, 30 rods to one.
Yeah, it looks like we got 15 to 30 rods converging to one bipolar. Very important question to write down and then to answer. What is the functional significance of this? What is the functional significance of why 15 to 30 rods converge into one bipolar? Is there any importance to this, mapping back to duplicity theory? 15 rods to one bipolar. So think about what was going on when I turned off the lights. At first, couldn't really see anything, but over time, what started working better? You were able to see better, light and dark. Question is why? What kind of circuitry is that? It's all additive. It's a convergent, very important for your notes, a convergent circuit. So if just a tiny bit of light comes into your rods, what's going to happen to that? It's all going to do what? What's going to happen to all that energy in the rods?
It's all going to go straight towards one bipolar cell.
It's all going to add up. And so eventually, what are you going to be able to do? See. Functional significance. The rods, the energy converges, and then you can see. So I'm going to move down to B here. This is in your book as well. Actually, I'm going to switch it up just a little bit here. I'm going to go down to C here first before I do B. In the picture C, does anybody know what the word acuity means? Acuity. Acuity. Hold on for just a second. Acuity. Temp loop. Striate cortex. Acuity. Trying to give you a little clue there. What does the word acuity mean? Didn't work? Not even funny. Nope. Missed it both times. Okay. My dad used to say, and I think I said this to the folks last semester, people are either laughing at my jokes or laughing at me because I told the jokes and they were so stupid. But what is acuity? People should know what the word acuity means. The ability to see what? Fine detail. The ability to see fine detail. Does this thing actually work? I don't think so. The ability to see fine detail. Can you read people's name tags now? You can. Rods or cones? So I heard rods over here. Why was the answer rods?
Rods help you see more fine detail, and then cones help you see more like abstract things.
So more abstract things. The other thing I wanted to say, in a constructivist-based teaching way, when answers are given, and sometimes answers are given and they're not the right answers, and if you're a constructivist-based teacher, is it good if people actually say things that are sometimes incorrect? Actually, the answer is very much the way. We like to learn and find out what your logic and knowledge is. The truth is, it's actually the cones that are really focused in on acuity. It turns out that if you look at this, and actually I didn't even notice that in the classroom here, if you look at the back, when I walked in here this morning, kind of got the picture of the brain, information. Not that this is a big deal here, but there's, for those in the online class, we have a brain model in the back of the class, plastic brain model. Information, as you look at those circuits, they're going basically from your cones, which are more centered where? Does anybody know where your cones are more centered? Actually, I don't think we've even said that yet. Where are most of your rods? Are they in the center portion of your eye, or are they in the periphery?
Center? No, periphery.
They are in the periphery. They are in the periphery. Often called, the cones are much more concentrated in the center portion. What is the structure in the center portion of your eye? The fovea. So we often say there are a lot more cones in your fovea. We say there are a lot more rods in your para, P-A-R-A, fovea. And for the cones, how do those connections look? Do they look like they're converging all over the place? How do they look? The circuitry for the cones is much more linear. They are non-converging. What is the functional significance of that? What is the functional significance of that? I'm holding up somebody's... Oops. Sorry about that. If I ask you to read this, what part of your eye are you working with to read somebody's name tag? You're using your parafovea or your fovea? Your fovea. You're using your fovea. Because your fovea has the cones in it, and the fovea makes basically a linear connection all the way back to the occipital lobe. So you can see what? Fine detail. Could you see people's names when the lights were off? No. So for acuity, the cones are better. That's a behavioral skill. Color vision. What works better for color vision? Rods or cones? Cones. We've already kind of spelled that out here. I don't know if I said anything under that. Actually, we can say a little something under that. It turns out that in your cones, you actually have receptors. Look what it says here about the cones. Where are the cones located? In the parafovea or in the fovea? In the fovea, you actually have in your fovea cones that respond to short wavelengths, medium wavelengths of light, and long wavelengths, so you can discriminate colors. I can read Berlin on a shirt. So duplicity theory says the rods and cones do different things, and very importantly here, I haven't said an important word yet. We go back up. The word cytoarchitecture. Do you see that on number 3 on the outline? Cyto means what? What does the word cyto mean? Cyto stands for cell. Stands for cell. The architecture of these cells basically gives you your functional skills. So it's the cytoarchitecture of the system. The rods have converging circuitry. That's their cytoarchitecture. They allow you to see in the dark. The cones are much more linear. They respond to different colors. You can have color perception and better acuity since they make linear connections back. This is all part of, what theory did I call this? Duplicity theory. I think we have one more content-based thing to cover here. Okay. So the last thing I kind of wanted to cover here, and then we'll tell you about some book pages. It took some time, didn't it? It took some time to actually figure out and learn how to see things. What did we say was at work here? Your rods or cones when I turn the lights off? Your rods. It turns out that the rods take about 15 to 20 minutes as that line goes down in B there under dark. You were adapting to the dark. I think I made some jokes last semester. If you've ever been in a room and, being married 26 years, if I come into the room very late and my wife has had the lights off for a period of time, she might still be awake, and what will she see me doing? Stumbling around trying to find my way because she's dark adapted. You are basically doing a dark adaptation experiment. The reason this happens is because of what's called visual pigment regeneration. The visual pigment in the rods takes time, takes about 15 to 20 minutes where you can see in the dark. Takes time for those rods to make that happen. Does that make sense to people? So can you see what I'm doing here today? You're writing a lot of, would you call it, are you writing out outline-based information, or are you just taking a lot of notes here? You're taking a lot of notes, so my way of assessing if you're really getting all this, I'm not doing open book, open note tests, but it'll be, can you actually listen to the acoustics and integrate it in? The last thing I wanted to cover is to kind of map this back to the book.